Alright, and with 2.4, it's different linear forms. Now, the good thing is with this one, we're going to go back and review the one form we had yesterday. So there's three main forms we're looking at. The first one is the y equals mx plus b form. And we did this one yesterday in 2.3. We talked about it just a little bit. That's your slope-intercept form. That's the one you're going to use to graph with the m and the b and work through and do everything. The one thing we didn't get to yesterday that we get to here is the second one, and this is the one that's kind of important. And again, hopefully everybody remembers that one in the past. Y minus y1 and m times x minus x1. That is the point slope form. Now, they call it point slope form. I kind of like to call it the point slope formula. Kind of like the Krabby Patty secret formula, right? But here's why I call it the formula for this one. I always put a star by this one, because here's what I tell people. If you get stuck, because a lot of times people go through a problem, some of these problems, and sometimes they'll tell me, hey, I don't know where to start on this thing. If you get stuck and you don't know where to start, start with this formula. Because I've always had people in the past, they're like, well, they would do a problem and just not know exactly what they were doing. They're like, well, I don't even know where to start. So I started telling them, all right, well, once some people started telling me that, I said, all right, well, let's just make sure that if you get stuck and you don't know where to start with the y minus y1 equals m times x minus x1. Because what we're going to do today is we're going to take this form and turn around and change it to y equals mx plus b form. That one you can do. It's hard to go from here to here. It's really easy to go from this formula to this formula. So we're going to say that anytime you do some of these problems and you get started off on it, 90% of the time you won't start here. Now, occasionally they'll give you one where you've got information here, but most of the time you won't start with this one. Okay, and the third and last one that you're going to use pretty much just for some shortcuts, and we'll show you that one at the very end, is ax plus by equals c, and that's the one they call standard form. And the one little small thing they kind of say on this one, which is really not that big a deal, they say that when you're using the a, the b, and the c values, that these are going to be real numbers. Usually those are going to be integers. So now again, the reason why we stick with integers is, if those are fractions, people usually don't like fractions. So we kind of go ahead and say, all right, when we're working through these things, let's just make it integers. That way it's a little bit easier to work through the problems. And really, when we do some of the shortcuts, you're going to see why this works out when those are integers for what we're doing here. Okay, now here's kind of the one exception when you wouldn't start with the point slope formula. If they give you the slope and the intercept, that's one where you don't have to start with the y minus y1, because if they give you the slope-intercept, you've got everything you need to write it in slope-intercept form, because that's the two things you're looking for. So if they give you one like this, this is almost like so easy that sometimes people make it harder than what it is, because it's almost like a trick question. Well, the slope is 3, so that goes there. The y-intercept is -2, that goes there, and that would be your equation. And somebody's saying, well, that's too easy. Well, occasionally they're going to sneak an easy one in like that on the homework, just to make sure that, you know, if they give you just the slope and the intercept, you don't have to do any rearranging. You can just plug those numbers straight into that formula, and then you're done. Okay, now, the rest of the ones we're going to do, or the next two anyway, we're not going to have it where you've got just those two pieces where you can just plug it in. These, you're going to have to actually work it out a little bit to kind of get to where you've got to be able to write it in an equation form like that. So for this one, direction is going to be a little bit different. For this one, we're going to write the equation of the line. I'm going to write it in point slope form first. And then the part B, we're going to write it in slope intercept. Again, we're going to start here because most of the time, now again, unless they do like this where they give you the slope intercept, if they give you anything other than those two values, you've always got to go to point slope form first. We don't have to, but it's an easier way to start here, then work it, rearrange it till you get to where it looks something like this. So I'm running off the end of the paper, so let's just start. Back over here. Okay, so again, here's where they're giving you two different pieces of information. You do have the slope, but you don't have the y-intercept. They just give you a point that's 7, -1. Alright, and kind of like when we were doing the slope yesterday. Label the numbers and the information you get for this thing. Your slope is -3, so that's your m value. Now, this is the only point they give you, so this is x1 and y1. Again, don't make it too complicated. Keep things simple when you're going through this one. So we're going to start with the A part, which was y minus y1 equals m times x minus x1. Let's cover up the B part for now because we're not even doing it yet. So there's our point slope form, and we're going to plug in the -3 for the m. That's x1 and y1, so that's y minus y1 is -1. And I would say, especially when you're plugging in negatives, I'd say put that in parentheses just so that you know that there's a minus and a negative there. Then we've got x minus, the x1 is 7. It's not a negative, so we don't have to put a parentheses around it. Okay, now you only have to do one thing to get the answer for part A. You've got minus a negative, so let's make that a plus. We've got -3, and before you do distributive property, kind of hold on because that is your answer to part A. And again, if we go with the KISS method there, it's pretty simple because all you had to do was plug in the numbers, and the only thing you have to do is if you have a minus a negative, you change that to a positive, and that's it. Everything else is staying the same. So there's part A. Okay, to get to part B, and somebody may be saying, well, but what about distributive property? I want to do the distributive property. Okay, that's the part B. Once we've got part A, for part B now, we're going to take that same equation we've got here, and you are going to do distributive property with the -3. So we've got -3 times x for -3x. -3 times -7, that's a positive or plus 21. And then the only thing left to do to get y equals mx plus b form, we've just got to get rid of this plus 1 that's here. So then we're going to go -1 on both sides. And there's our Part B answer. Okay. And I think in most of the homework problems, they're going to ask you to do Part A first to get it here. Once you've got it here, then they're going to ask you to go ahead and go down to Part B to get those two things. And again, almost every single problem that you do, you're 90% of the time, you're going to start with this one, plug in whatever information you have. Once you get it here, then it's real easy to get it from here down here, because you're going to do distributive property and then add or subtract away this number that's on the side. So that's why we say that if you get stuck and you don't know where to start with this one. And once you get it here, you can always take that and rearrange it to make it look like that. All right, let's give you another one with a little bit different information for this thing. Same directions, we're still going to do the Part A and the Part B. But this time you're given, instead of the slope and the point, this time we're just going to give you 2 points. Okay, and again, let's keep it simple, right? Because here's the first point, so that's x1 and y1. Here's the second point, so that's x2 and y2. All right, now, we don't have, back here we had the m value, but go back up real quick. To make this thing work out, we had the slope and we had the point. Well, for this one, we've got 2 points, so it's a little bit different lineup. So here's what you want to do. Another little star here. Here's the second important thing. If you have 2 points, now I'll put a comma there. I'm not sure if I'm supposed to or not, because I got kind of comma phobic in high school. Because I got a teacher who, I would put a comma and they would say, well, you don't put a comma there. And I was like, well, I did. They said, well, you don't put a comma when you pause. I'm like, but I paused there. And they would say, well, you're not supposed to. I'm like, but I did. So I got real comma phobic for a while. I'm still kind of fighting through that 30 years later. But, you know, I'm getting there. So I'm not sure if we need a comma there or not, but I paused, so I put a comma. If you have 2 points, find the slope. Every single time. Now, there may be one exception to the rule, but every single time in this chapter, or anytime we're doing anything with a line, if they give you 2 points, you have to find the slope. You're going to have to use that slope somewhere through the problem when you're going through this thing. So here's where we're flashing back to yesterday. To find the slope, it was y1 minus y2 over x1 minus x2. And again, I'm using the y1s and the y2s first because I want to put the first point first and the second point second. Because to me, it just makes more sense to do it that way. All right, y1 is 2. The y2 is 7, so that's 2 minus 7. x1 is 3 minus 0. All right, 2 minus 7 is negative 5. 3 minus 0 is 3. So now we've got the m value that we needed here. And once you've got the m value, well, now we can jump in and start doing Part A. Because we got the x1 and y1 from here. x1 was 3, y1 was 2, and we've got our slope right here, which was negative 5/3. Okay, and neither one of these two are negative, so when we plug it in, we've got y minus 2 equals, we do have the negative 5/3 and then x minus 3, but there's no minus the negatives. So for that one, once you plug in the numbers, well, that one worked out really nice. You just plug in the numbers, and that's it. That is your answer to Part A. The only work you had to do for this one was to find the slope between those 2 points. All right, now that you've got Part A, this is where we're going to do distributive property to get the B part. Okay, so for Part B, slide this up just a little bit. There we go. So part B, now we're going to take that same equation that we have, and we're going to do some distributive properties. Now, for those of you that are worried about the fraction, it's actually going to work its way out here and be okay. Because if you do negative 5/3 times x, that's just negative 5/3 x. When you do negative 5/3 times negative 3, you put that 3 over 1. And in this case, those two negatives are going to cancel each other out, because that would make it, if you did multiply it out, it would be 15 over 3. But 3 will go into 15 5 times, so those 3's cancel each other out. It's negative 5 times a negative 1, so it's going to be a plus 5. Now, on the odd chance that that happens to not work its way out, that's one where you can probably do decimal numbers, that if this came out to be a fraction or a mixed number or something, you know, you could just leave it there and then you could go back and, because the next step then would be to add this 2 back over. And if that comes out to be a fraction, you just have to work with some fractions a little bit there. Okay, so once we've got this cleaned up down to the 5, we've got to get rid of this negative 2, so we're going to add 2 to both sides. And that will be the answer that we're looking for the B part. And hopefully that you'll catch and notice on these, the only thing that changes, the slope stays the same. We had negative 5/3 x up here. You also have a negative 5/3 x here. The only thing that changes is we're moving this number over here, so we'll know what the y-intercept is. Okay, so there's where you're starting with point slope and slope intercept, working with those two. The last two problems, we're going to show you some that's a little bit different, but one of them's a different form. The other one's going to be kind of a shortcut to help us graph some problems if they look a certain particular way. All right, and last, the problem we're going to do is kind of spin off this one. We're going to take this equation we have here, the y equals negative 5/3 x plus 7. And we're going to write this in standard form. And once you see the standard form part of it, we're going to show you one trick question that they're going to ask you to do to graph these, and we're going to show you a shortcut you can do on these. Okay, here's where we're having a flashback to last week. We've got this equation, and it's got a fraction in it, right? We don't like fractions, so let's multiply by something to get rid of the fractions. The good news is this is the only fraction. So to get rid of the fractions, we just need to multiply everything here by 3. And if you do that, we've got 3 times negative 5, but then you're going to turn around and divide by 3. So since you've got 3 divided by 3, just cancel those two things out. So that makes that 3y equal to negative 5x plus 21. And again, we're going to keep using that same get rid of a fraction strategy over and over and over. So if you didn't get it on the first test, you got a second chance coming out. We did the same thing with it yesterday. We had some problems where we got rid of some fractions. So we'll keep doing that same thing. And for standard form, again, that was ax plus by equals c. So we've got to get the x and y on the same side. So let's move this 5x from the right side, and let's move over here to the left side. And once you move it from the right side to the left side, now you've got it in standard form. Okay, and the last thing we're going to show you, and this is where it's almost a little bit of a shortcut to use some problems that's in standard form, and this will be most of the problems that you're going to get. That they're going to ask you to find some x and y intercepts. Okay. So for these, we're going to be finding x-intercepts and y-intercepts. Now, for what we're going to do for now, there's only going to be one. You're going to have one x-intercept and you're going to have one y-intercept because we're doing linear equations. Later on, when we get into quadratics where we start having some curves, then we might have one, maybe two sometimes. But just it'll depend on the problem. So, but to find an x-intercept, plug in y equals 0. And once you plug in y equals 0, that makes the y value go away. So once you plug in y equals 0, then you solve for x. And to find the y-intercept, it's just the opposite. Now you're going to plug in x equals 0. And solve for y. And what this does is basically on these equations, when they tell you to do this, they're giving you a shortcut so you don't have to find the slope and the intercept. That they give you a problem that say, all right, well, here's one option you can do if the problem sets up kind of nice. There's a shortcut you can do to graph these. So we're going to show you this part of it. All right, we'll show you one example of this one to kind of show you what's happening here. So they're going to ask you to find the x and y intercept. And graph the line. X minus 4y equals 8. So first thing is we're going to find the x-intercept, then we're going to find the y-intercept, and you're going to use those two values to help you find the graph of the line, and it's going to be a shortcut because once you get those 2 points on there, you just connect the dots and you're good to go. You don't have to worry about finding the slope and moving up and over. This one, they give you this one because sometimes there's problems where you can do a shortcut. Sure, we could take this and rewrite it in y equals mx plus b form, but they're going to kind of show you this one because sometimes there is a little bit of a shortcut that'll get you a faster answer a little bit easier. Okay, so for x-intercept, again, you can almost just kind of split this in half because it won't take us very long here. For the x-intercept, this is where you're going to plug in y equals 0. So that's 2x minus 4 times 0 equals 8. And the good news is when you do the intercepts, when you plug in 0, what happens to this y value right here? Well, that's just going to make it 0, right? If that's 0, then it doesn't really do anything. That's 2x equals 8. 8 divided by 2 is 4. Okay, now they should ask you to write the answers in order pair. So if you do that, x value goes first, y value goes second. And for the y-intercept, we're going to do exactly the same thing, but just do it in the opposite. That for the y-intercept now, instead of plugging in y equals 0, you're going to plug in x equals 0. Again, that'll make that 0. If it's 0 minus 4y, well, that 0 doesn't do anything. That is just negative 4y equals 8. So now you're going to take 8 divided by negative 4. So the y value is negative 2. And for your ordered pair, this one we let x equal 0. And the y value was negative 2. Okay, now that's showing the work. Here's a lot easier way. When they ask about the x-intercepts and the y-intercepts, here's a lot faster way to do that. Because this is technically what you're supposed to do. Here's what I would say to do just to make it easier. When they ask you to find the x-intercept, all you have to do is just cover up the y value and let 2x equal 8. 8 divided by 2 is 4. And when they ask you to find the y-intercept, you cover up the x value and just solve it for y. Negative 4y equals 8. 8 divided by negative 4 is negative 2. So, that's technically what we're doing when you're working everything out and plugging in. Really what you do is you just cover up the x, solve it for y. You cover up the y and solve it for x. You got your two numbers. Now, the reason why we write them as ordered pairs is when they ask you to graph this equation. 2, 3, 4, 1, 2. You're going to put one dot at 4, 0. And you're going to put another dot at negative 2, or 0, negative 2. Connect those two dots, and there you go. There's your graph.